Hello students, this is Ingrain. Welcome to the channel and welcome to the new video. Today we will continue chemical changes and reactions. In this chapter, you are expected to learn the concept of chemical change and chemical reaction, characteristics of chemical reaction, types of chemical reactions, energy changes in a chemical change, and factors affecting the rate of chemical change. Out of which we have already covered the concept of chemical change and chemical reaction, characteristics of chemical reaction, and types of chemical reactions in our previous episodes. For all the new viewers, please watch the previous episodes from the suggested link appearing on the screen to have a complete understanding of the chapter. And if you like the videos, do hit a like and subscribe the channel for all the latest updates. Today we will cover the energy changes in a chemical change and factors affecting the rate of chemical change. We have already come to know from our previous episodes that various atoms in a molecule are held together by bonds, and the old bonds are broken and new bonds are formed during a chemical reaction. Now, for breaking the bonds, energy is required, and for making the bonds, energy is released. You can see over here, energy is taken in when the bonds are broken, and energy is given out when bonds are formed. The energy required to break the bond in reactants is not equal to energy released due to the formation of bonds in product molecules, and thus some energy is either absorbed or released during a chemical reaction. Basically, energy is absorbed during a reaction if the energy required to break the old bonds in reactants is greater than the energy released during the formation of new bonds in products. So if the energy required to break the bonds is greater than the energy released due to the making of new bonds, then overall energy is absorbed. Similarly, energy is released during a reaction if the total energy released during the formation of bonds in products is greater than the energy required to break old bonds in reactants. Now, depending on the energy changes during a chemical reactions, the reactions can be of following types. The first is exothermic reaction. It's a chemical reaction which proceeds with evolution of heat energy. That is, heat energy is released out. Plus delta T denotes an exothermic reaction, and this reaction can be sustained without the supply of external energy. Let's take some examples. N2 plus 3H2 gives 2NH3 plus delta T, and 4NH3 plus 5O2 gives 4NO plus 6H2O plus delta T. So in this reaction you can see that there is plus delta T, which denotes an exothermic reaction. In this type of reaction, heat energy will be evolved or released. The next type is endothermic reaction, which is a reaction which proceeds with absorption of heat energy. Here, minus delta T denotes an endothermic reaction, and this reaction cannot be sustained without the supply of external energy. So it is just the opposite of exothermic reaction. Let's take some examples. When N2 reacts with O2 in the presence of heat, it forms 2NO. And when C plus H2O reacts in the presence of heat, it forms CO and H2. So in this examples you can see there is minus delta T, which denotes an endothermic reaction. Now, heat change during a reaction is represented by delta H or enthalpy. The details of enthalpy we will study in higher classes. For now, you just know For an exothermic reaction, delta H is negative, and for an endothermic reaction, delta H is positive. And remember, this delta H and delta T are different. The third type is photochemical reaction. It's a reaction which proceeds with absorption of light energy. From the word photo, you can understand there is an involvement of light energy. Let's take some examples. It is photosynthesis of carbohydrates. Now this reaction is known to you from junior classes. 6CO2 plus 12H2O in the presence of sunlight and chlorophyll, it will form C6H12O6 plus 6H2O plus 6O2. So you know photosynthesis occurs in the presence of sunlight. So it's a photochemical reaction. Similarly, photodissociation of I2 or iodine will require the absorption of light. So I2 in the presence of visible light will form 2I. It is basically a dissociation reaction. Also, formation of HCl gas. When H2 reacts with Cl2 gas, in the presence of diffuse light, it forms 2HCl. Now here you remember, this is not direct sunlight, it is diffuse sunlight. The next type is electrochemical reaction, a reaction which proceeds with absorption of electrical energy. For example, electrolytic dissociation of acidulated water. When electricity is passed through acidulated water, it dissociates into its respective ions and gets discharged at respective electrodes. That is 2H2 at the cathode and O2 at the anode. Similarly, electrolytic decomposition of molten sodium chloride. When we pass electric current through molten sodium chloride, it dissociates into its respective ions, that is Na plus and Cl minus, and gets discharged at respective electrodes, that is Na plus at the cathode and Cl minus at the anode. By this time we have already come to know what is a chemical reaction, what is a chemical change, and what are the types of chemical reactions. Now let us study the factors affecting the rate of chemical change. For a chemical reaction or chemical change to occur, the particles of the chemical substances needs to collide. But all collisions among reactant molecules do not yield products. The reactant molecules should be associated with a certain minimum energy called the threshold energy, so that the collision between the molecules are strong enough to bring about the chemical reaction. There are various factors or conditions that controls the rate of collision between the particles of reacting substances, which in turn controls the rate of chemical reaction or chemical change. So you can understand that how important these collisions are, and to bring about these collisions there are various factors. The first factor is heat. Heating initiates the reacting particles to move faster and collide more frequently, hence it increases the rate of reaction. So when Pb3O4 in the presence of heat, it changes to PbO and O2. It is basically the number of collisions between the reactant molecules increases, and hence the rate of reaction increases. The next factor is light. The reactant molecules absorb light energy to become activated and collide rapidly, and hence it increases the rate of reaction. When H2 reacts with Cl2 in the presence of sunlight, it forms 2HCl. The third one is electricity. The ions are directed towards the opposite electrodes in the presence of electricity, and hence it speeds up the chemical reaction. When acidified water is taken and electricity is passed, it forms 2H2 and O2 at the respective electrodes. The next factor is pressure. Reactant molecules clusters together under high pressure, leading to the increase in rate of reaction. When N2 reacts with hydrogen at 200 atmospheric pressure, it forms NH3. This reaction is not possible without this appropriate pressure. Next is sound. Some chemical reactions takes place only by absorbing sound energy and which speeds up the rate of reaction. C2H2, in the presence of sound energy, it forms 2C plus H2. Next is close contact. Now close contact is a must for some types of chemical reaction, and this close contact is possible by either grinding the reactant molecules or by taking one of the reactants in solution form. 8GCl2 plus 2Ki will form 8Gi2 and 2KCl. Now this 8Gi2 is deep red in color, and this reaction is possible when the reactants are thoroughly ground or dissolved in water. The next factor is catalysts. Some chemical reactions takes place by the use of catalyst, which alters the rate of chemical reaction without themselves undergoing any chemical change. This catalyst can be of two types. Positive catalysts, which accelerate the chemical reaction. 2KClO3 in the presence of MnO2 will form KCl and O2. Here MnO2 is the positive catalyst, which accelerates the chemical reaction or speeds the chemical reaction. The other type is negative catalyst, which retard the chemical reaction. 2H2O2 in the presence of H3PO4 will form 2H2O and O2, but this chemical reaction is retarded by the presence of H3PO4. So H3PO4 acts as the negative catalyst over here. With this, we complete this chapter. Hoping that today's elementals are embedded, we encourage you to take up the self-check assessment. This segment is specially designed to test your understanding of today's learning. When ammonium nitrate is dissolved in water, it becomes cold. Why? Write a balanced chemical equation for photochemical reaction and exothermic reaction. What is the main requirement for a chemical reaction to occur? Explain why temperature increases the rate of chemical reaction. Give an example where a positive catalyst brings about a chemical reaction. As we have completed the entire chapter, the solutions of all the self-check assessments of episode 1, 2 and 3 will be discussed in the next video. So don't forget to subscribe the channel and hit the bell icon to get all the latest updates. Also post your comments in the comment section and don't forget to give a like to our video. Meet you in the next video. Till then, take care and study hard.